coming out and just taking the time to learn some code, right? So just a quick note, just before we get started here, next Monday after our regular session, we're going to have a club at the UFC. I believe it's the solar car team, or solar car engineering team. And they're just going to have a 20-minute presentation and kind of demo of the software that they use in their solar cars. So that should be really interesting. And if you just have some extra time next week, just please stick around and kind of make it worth their time. We'd really appreciate it. And without further ado, hopefully everyone has kind of trickled in, but I'm just going to jump right into the content. It's session 5. So after this one, we'll have 2 more, and then we'll have a nice gala where we present our projects and everything. So we're kind of going to be jumping more into Pygame and the actual game development side of things. So we're going to be talking a bit about sprites, just some review, and I think we'll also have us just bring in a sprite that we'll need for some of the exercises. We're also going to talk about physics, and we're going to start actually roping in physics into our game, specifically involving the player. And then we're going to talk a bit about collisions, and then we're going to leave it up to you to kind of bridge the gap and bring both the player physics and the collisions together to kind of get a basic platformer started. So there's a lot happening today. But we're going to give you lots of time to just cover everything and do the exercises. So hopefully you'll enjoy that. Okay, so before we overwhelm you, I'll just talk a bit about what we covered last week. So we talked a lot about sprites, and more specifically, I'll just cover a few of the more important things that you need when you're working with a sprite. So first and foremost, we're going to start with the fairy class over on this side. You're pretty much always going to want to have this constructor here. So def __init _self. And then you always want to make sure that you inherit from the Pygame sprite class, that you take all of the properties and stuff that it sets up in its constructor, and you just bring that in as well. And that's done with this super function, or well, the super.init function. And then the update is just kind of an extension of our while loop. You just throw that in the update section, and that way you kind of can keep the fairy code separated from the rest of your game code. It makes it a lot easier to see what's going on when you find bugs or trying to fix things later on. And then, of course, we also talked about sprite groups, which is how you bring sprites into your game and how you keep track of them. Makes things like drawing them and updating them much easier. So basically what you do is you call pygame.sprite.group to create a group. You assign it to a variable, and then you can just use the add function to add sprites to that group. And of course, you'll have to actually create a sprite before you do this. And then that way, instead of calling each and every sprite in your game and updating them one at a time, you can just take the sprite group and update that. And then you can also draw them all together as well. So it makes our life a lot easier. So now that we've talked a bit about that, I'm just going to ask if anyone has any quick questions, either about last week or about sprites in general, just before we move on. Hopefully everyone's doing well as well. Can I get anything in the chat? Some activity? Hellos? Thumbs ups? Okay. Perfect. All right. So some of you there getting engaged. Good job, guys. Thank you. So let's talk a bit about physics now. They're kind of what makes your game exciting, right? So you can generally kind of think of physics as the set of rules that your game follows. Pretty much in any 2D game, there's always going to be gravity, unless it's an RPG. But stuff like platformers obviously have gravity. Projectiles use physics, and then collisions are involved in physics. And you'll soon learn to realize that dealing with collisions is actually kind of a pain in the butt, but they're really vital to making your game kind of function, right? So our goal just to make our game more realistic. Obviously, we want it to be a fun game, so we're not gonna like be super stringent about like the exact physics used, but it's a good model to kind of base our games off of. So I'm sure we've all played Mario at some point or another. This is like the prime example of a platformer, right? So we'll talk a bit about how to actually get started with a platformer. And as I said before, you guys will actually get to do some of this yourself. So please, please, please just pay attention to what we're going to be doing, because you will have to do it yourself in like the next hour. So first and foremost, let's talk about velocity. We're going to be calling it speed just because it's easier to type and it's a bit faster to work with. But speed is how fast an object is moving and is tracked using a variable. Speed or velocity is typically added to the position of an object once per frame. So you'll see inside the setup section, or in this section of code here, we just have like constant speed. So our speed is just 2. And so every frame, our ball in like the video there is just moving to the right by 2 every frame. So we get this nice smooth motion. And then you actually have to update this in the position of the ball, but this should be pretty familiar to you by now. We've used it a lot. So let's talk a bit about the more exciting ones. So I just want to really drill this in. Acceleration is the increase or decrease in speed over time. So acceleration is used to change the speed that you're traveling. So a good example is gravity, right? So if you just look in this GIF here, you'll see it might not be super apparent right away, but this ball is actually getting faster, or it's starting to fall faster as the GIF kind of progresses there. So basically how we implement acceleration, you just want to make a really clear note of this. It's super important, is that in your update section, we talked about how it's the increase in speed over time, right? So in your update section, you're going to want to take your speed variable and you're actually going to want to like mutate it like it does here. This is absolutely essential. Otherwise, you'll just have the same like kind of linear motion and it won't get faster or slower. And then of course, you just keep the same line as you did before to implement the speed. By just adding the speed to the position. And so I believe this takes us into our first quick question. So let's say that we have the goal of creating a ball that moves with acceleration, what I just talked about. What is the problem with this code over here? So some assumptions that you're free to make are that we actually have created the ball and it has the member variables ball.rect.x and ball.rect.y. I'll just kind of stick with the terminology and stuff that we've been getting more familiar with, right? So without further ado, hopefully we'll have a poll popping up here. But
yeah, just 1 second.
Okay, sorry about that, AJ. Oh, okay. All right, we're already getting off to a pretty good start here, although it's looking a bit divided. Okay, this is actually kind of fascinating. There's more disagreement than usual. All right, so let's give it a bit more time for this to kind of wrap up, but I think there's just a few extra people I just need to answer, so we'll give them a bit more time to think about it. What's going on though? How's everyone doing this week? Okay. So it looks like most everyone has answered, so I won't waste any more of our time. Basically we had 4 options here. So we had the y coordinate position is not changed. We only had 1% on that, so it's not the biggest one, but there's this big kind of divide between these other two. So a lot of you said that the speed of the ball does not change, and that would be correct. And then just kind of like a similar answer here is that the variable gravity is not used. That part is correct, but that last little section where it says the code will not run, no, it will run. We just don't use it anywhere. We're kind of just wasting our time because we like write down this variable of gravity, but we actually never go ahead and use it. So just to kind of reiterate, if we go back here, acceleration is the change in speed over time. And so if we go back to this slide here, we'll see that we actually don't do anything to this speed. All we do is we set a constant speed, and then we just add this to position. So there's no change in speed happening at all here. And just to fix it, you would want to add the gravity to the speed here. And that way it would kind of accumulate as the game or as the loop or just as the program just keeps running, right? So the big thing that we want to implement today is jumping. And it might be a bit hard to believe at first, but to implement a jump, all we need are 2 things. So first and foremost, we have to add velocity. So we're going to be adding speed to our speed here. So we're basically just going to be incrementing this speed variable or this y speed variable whenever you want to jump. And I'll talk a bit more about how this actually works. But the important thing is to remember is that gravity is pretty much always going to be there for us. It's always just going to be bringing us back down. And so when we change the velocity like this, or we increase our speed on the upwards direction, gravity will help us take care of actually lowering it and then bringing us back down eventually. So just one thing that we'll need to keep in our minds as we kind of progress here is that just what I like to do when I'm programming these sorts of things is just moving the logic for our jumps into the player class, also to help keep our code more organized. I'll actually see that because I'm going to be implementing it in just a minute here. But one thing that we do need to remember for sure is that the y-axis is like kind of flipped in Pygame. So we start at 0 at like the top of the screen. And then as we get farther to the bottom of the screen, the y actually increases. So if you kind of think, if I'm going from the bottom to the top here, like I would when I'm jumping, I actually want to take away or like subtract position. So my speed will actually have to be negative when I like start out my jump. So let's talk a bit about the actual breakdown of when we jump. So at the very start of our jump, we're gonna subtract 10 from our y velocity. So suppose we're just standing, so our y speed is 0. We're gonna subtract 10 for that. So in this next frame or in this first frame here, we're gonna move up 10. And then since our gravity over here is 5, in the next frame here, our speed will decrease to -5. So we'll still be going up 5 in the second frame. But then our speed will become 0, right? So gravity is applied here again. And so our y speed becomes 0. And then at this point is when we kind of start to fall back down. So gravity, again, is constant. So in this fourth frame here, you add it again. And so your speed becomes +5. So you've changed direction and you're now falling. And then in the fifth frame here, we're going to apply gravity again, and our speed will change up to 10, and we're going to move 10 pixels again. Nathan kind of cracked a joke here about quadratics. If you don't enjoy physics, I'm sorry, but we're going to be talking a bit about it. But For the most part, we won't delve too far into the math. We'll just keep a really basic implementation, so don't worry about it too much. But does everyone understand what is happening here? Because it's just really important to like understanding how this all fits together. So if anyone has any questions, like please let me know like right away. Okay. Can I get some spam in the chat then, just so I can make sure you're all awake, not going to zombie on me? Okay, perfect. Thank you, everyone. All right. So let's talk a bit about the actual implementation we're going to do. So first and foremost, we're going to want two constants, right? So gravity, we're kind of going to be doing something similar. And this might seem a little low, but you'll see why. But our gravity is a positive 0.5. So if you just think about this in terms of velocity, if that was velocity, would be moving down half a pixel every frame. And again, that's just because of the coordinate system being the way it is. So that's why gravity is positive. And then in the same way, jump velocity is negative. So whenever we apply our jump velocity here, we want to go up. And to go from a high value to a low value, we have to add a negative value, right? So one thing that's new that we're going to be doing in this specific lecture is that we're actually going to move some of the key press logic into our update function. And this is just so that, you know, all of the logic that is involved with our player and our player's movement is all going to be in the player class. So it's a lot easier to find problems. You won't have to sift through the main class when that gets more complicated. And that's the reason why we do that. There's no like particular constraint. If you want to keep in your main class, be my guest, but this just makes more sense to me. But as we said before, all that we have to do to implement a jump is add more speed to our current speed in the y direction. The best way to learn this is honestly just to show you. So stick with me as I explain this last little bit, and I promise it'll be a lot more interesting here. But one thing that we always need to do, so it's on if statement, is add gravity to our y velocity or y speed. And then finally, we just change our position. So we just have to update self.arc.y and add our speed to it. So it's pretty simple kind of block of code. And all I'm going to do now is just bring that into our IDE. So if you'll give me a moment here, I'm just going to switch perspectives. Okay. So this is the wrong file. I'm just going to show you guys what we're starting off with. It's what we ended off last week. And so you can see that I can just move my player. There's no gravity, nothing. It just moves when I press my arrow keys. So the first thing that we'll probably want to do is add some gravity to this. So I'm going to open up our player class. And then in this updates here, I will want to add gravity. So we'll probably want to get rid of what we're doing here, which is just using the arrow keys to determine which direction we're going, and then actually moving in that direction. And we'll want to replace this with just a constant gravity. So self.rect.y, and then we'll just add gravity to it. And then one problem that you'll see here, it's already kind of complaining, is that we haven't actually defined gravity. So first, we're going to do that. And I'm just going to warn you that you'll want to make this really slow if you want to see what's going on at all. So I'm going to go 0.2 just to start off with. And so now we kind of have our player falling. So we'll just take a quick look at that. And of course, it's not working here. Here. Oh, wait, no, I think it's just because I made it so low. I should be more patient. Okay. Please. Don't you need to add gravity to the speed? That is correct. Okay, yeah. So this is actually a pretty interesting bug here. What I've done, and thank you for the advice, Kian. You're completely on the money. I'd like to say it was a test, but honestly, it was just me being a bad programmer. But basically, your position is all integers. And so if you add something that's less than 0 to it, like I'm just doing here, it's just going to round down to 0 and it won't actually add anything. So if we want to get around this just for now, we could change this up to 2, and then hopefully this will actually fall here. Exactly. And we'll see that that's the constant. Like it's not getting any faster as it's moving down. So we're going to have to do as Kian warned me, and we're just going to have to implement a variable for our speed. So I'm just going to do self.y speed, and I'm going to set this to 0. This should probably be in the init function. And then in the update function is where we'll actually want to change this using gravity. So we're going to take gravity away from here, and we're going to use it to change our velocity or speed. And so we're going to do that by just adding gravity to it. And so if we just print this out really quick, you actually see that this increases. So if we just look in the bottom here, it's just getting super, super big. And you just have to remember here that every value we see in our console here, that's how much we're moving per tick. So if you have a really high gravity value like this, like already just after like a few frames, we're already moving 40 pixels per tick. Our screen's only like, I think it was like a few hundred high. So you'd be flying off the screen super fast. So what we want to do is probably lower this a bunch. I'm going to go down to 0.4. And then just to illustrate this with our player, let's go ahead and add our speed to the player. And see what happens here. So go to our main. I will see that, hey, we actually did this right. Our player is getting faster as he falls. Does anyone have any quick questions before we move on here? No? Okay. Feel free to drop them in the chat. I'm not picky. But just kind of the next steps here is to actually go ahead and get our key input. So I'm just going to do this using Pygame again. So I'll do pygame.key.getPressed. And this will give us all the keys that are pressed, basically. And we're going to collect them in an array. I think that's actually a dictionary, my bad. But in any case, if we do a quick conditional here, we can check basically if a certain key is pressed. So we'll do pygame.space. And so this will ring true, or actually run the code down here. This will run, space is pressed. And this is why we just want to go ahead and add our jump velocity to our player. So do self.y speed, and we're going to add our jump velocity. Just so I can like tweak this later, I always like to put it in a constant at the top of the file. Jump velocity, and I'm going to set this to -20. Again, you just have to remember that because of the axis, it's a bit flipped. I like to have the -1 up where I declare it, just because it feels like more right to me when I go ahead and add velocity here. So we'll add that in, and then we'll just do a quick demo. First, I'm just going to make sure I'm doing everything right. So we apply gravity, and we apply our speed to the player. So we should have a proper implementation of jumping here. So I'm gonna go ahead and just play this really quick. And you'll see that I'm like flying upwards. I might have made it a bit too high. It's honestly a bit hard to tell. So I think I'm just gonna lower this a bit. And hopefully he won't just like fly completely off the screen here. Oh my. Okay. Here, just so I can get a better idea of what's happening, I'm just gonna print out coordinates. Oh, sorry. Okay, there we go. So right now I'm like moving really fast, so it's like kind of hard to see what's going on. But if we lower gravity, hopefully it'll be a bit more clear to us. So if we go to like, actually, it might even be too low just because it's not pulling us down hard enough. So when we jump, like we just go flying, right? So I think that's what's happening. Hopefully that'll be confirmed here. There we go. So now I'm kind of hovering, but you'll see that like it keeps boosting me up like really, really fast. And that's just kind of something that's like really hard to debug on your own. But to kind of bring this back under control, I'll first talk a bit about why I just like shoot up like that. So you just have to quickly remember that, hey, this game is running at like 60 frames per second. But whenever I press my my jump button, which is my space button, I probably hold it down for a few frames, right? Like it's not just one. So instead of just jumping once, I'm kind of just boosting my velocity as long as I hold space. And it gets really out of control really fast, just as we're kind of seeing here, right? So like it's like really hard to just stay on the screen unless I'm like really just tapping. But as soon as I hold it at all, I just fly off. And so a quick way around this is to just add a cooldown to our jump. And so just to kind of show you guys what that's going to look like in like the simplest terms, all we're going to do is introduce another variable here called jump cooldown. And then only when this is 0 are we going to allow this change in velocity to happen. And then we're going to set the number of frames that we want to wait before the player can jump again. And since this is, I believe it's 60 frames per second, so 30 frames would be half a second. And then if we only do this once, we'll only be able to jump once. So we have to make sure that we actually decrement this when it's greater than it should be. And then we don't want to change it when it's 0, just because that's what our condition is checking. So I have to make sure that this is like strictly greater than that we go ahead and decrease this. And so basically what's happening here is that when you jump, it sets the cooldown to 30. And then every single frame, it decrements by 1. And so after 30 frames, it will be back down to 0. This condition down here will stop passing, so it will stop counting down. And so our jump cooldown will just stay at 0. And this condition will just be waiting basically to hear that, hey, we're jumping again. So let's go ahead and implement this in our code. So we'll have an if condition here, and we'll do if self.jump cooldown. This one might have nudged the mic on, so I apologize, but I'm gonna try and track you down and mute you. I'm not sure if I can find them, but please just check your mic and make sure that it's off if it's supposed to be. So we're just gonna have to bring in our jump code into this if statement by indenting it. And then actually kind of have to finish the condition here. I got a bit ahead of myself, sorry about that. But if our jump cooldown is equal to 0, we're basically gonna allow ourselves to jump. And then we're gonna reset the cooldown. just by setting that to 30 frames. And then in the rest of our updates here, we're gonna want to make sure that basically if we get the chance to jump again, self jump cooldown is greater than 0. So if it's like 30, 29, 10, we're counting down all the way until it reaches 0. And we do this by just decrementing by 1 using the minus equals in the same way that we use like plus equals, right? So now if we go ahead and run this, I don't know if I just closed that too fast or if I ran into a bug. So I just can't scroll here unless I move all my camera stuff, but we'll see that I made a mistake. And basically, when this happens, it's basically checking for a cooldown before I set it. And when you get an error that looks like this, where object has no attribute, that just means that you need to go up to your init function here and just make sure it exists before it is called. So we'll go ahead and take care of that. I didn't jump fast enough. Okay. So you'll see that even when I jump, I like basically keep flying down. So that tells us like 2 things. Either gravity is too strong or my jump velocity is not high enough. So I'm just gonna like level them out a bit more. Then hopefully we'll have a more balanced jump here. And you can kind of see that, hey, I'm not flying off the space and I'm not like flying off the screen either. So we have a nice like balanced jump mechanic. And I hope you guys are paying good attention, just because if I put the slides here, the next thing that you guys are going to be doing is basically doing this yourself. If you really want to, you can replace or like build off of a player class or just a sprite class using the bird. But just for the sake of getting going, I'd recommend that you just start with like a simple box and just draw that. And just to give you some time to do this exercise when we're splitting off into our breakout rooms for like another 25 minutes. It's a long time, so please, I'm just going to share the slides in the chat again. But please take your time and actually go ahead and do this, because I promise you, you'll learn a lot.
Guys, make sure you join the breakout room. Let me know if it's not working. There we go.
Okay. Okay, welcome back, everybody. We give you just a ton of time for that exercise, so hopefully you guys could figure it out. I'm not going to spend the time to go over it again, just because I kind of went ahead of it beforehand. So without further ado, it's going to jump into collisions and start working with that a bit. Hopefully the exercise went well. Again, if you have any questions, just reach out in chat or to your mentor or even on Discord, and hopefully we'll be able to help you out. Okay, so first let's talk about what a collision actually is. So you may have noticed that if you had a game like mine, your player just kind of flies through the platform, right? So collisions help us stop this. So collisions are when 2 things, in our case sprites, that's what we're interested in, overlap with one another. This graphic is actually like pretty good, so it just kind of shows the overlap between these 2 here. So This is basically everywhere in games. It's what keeps you like on platforms. It's what keeps you in the world. If in like FPSs and stuff, it's what actually detects and like makes up the actual game. So you can do it when players hit platforms, bullets hit enemies, when you collect the coin to stop you from falling. All of those are handled by collisions in one way or another. So let's talk a bit about how this is actually done in Pi games. So to detect collisions, sorry, we use this big long function here. So it's pygame.sprite and then .collide rect, and then we give it basically two sprites that we want to check, and it's nice and simple. So it returns true if sprite 1 collides with sprite 2, and false if they don't overlap with one another. So just to kind of illustrate how we would use this function, again, I'm just going to pull up my IDE. And instead of the code that we just worked on, I'm going to go ahead and copy last week's session. So I'm just going to delete those. Okay. I'm just going to go back to the code I had from last week's session, and then we'll plop it down in here. Okay. And then hopefully. Okay. I think I just need to change the path here. Okay, sorry about that. But basically, we'll go back to what we had where we're moving up and down. And so I'll just kind of show you how this collision function actually works. I'm going to go down to update. The first thing that we'll notice is that, hey, we can't use the sprite function because this platform isn't a sprite. So basically, I'm going to drop in chat something very useful. But it's going to be the updated platform code that I mentioned last time. We're just going to want to take all of this, copy it, and then we'll just want to paste it. It's replacing all of this. And basically, it just has this nice platform texture here. And it replaces the rectangle platforms that we had before with a nice texture. And we can use all the sprite functions with it. So some overhead is actually needed to get us started. So we'll have to delete the old ones. Use a sprite group. So we'll do sprite. I'm going to name mine platforms. That's my sprite group. Then we also just need to create a platform. I believe the arguments for this, we'll just have to check the unit constructor ourselves. But it's X, Y, the width and the height. So it's just like a rect. Do mine about in the middle of the screen at the bottom. And then the width, I probably want it to be a few hundred. So let's see that we have an issue here. And again, this is just because I didn't fully implement the sprites over here. So if you recall that sprites are actually drawn differently, I'll use the sprite group, so platforms, and then we'll do draw. And we'll pass it to the screen, just like we did with our player. And then we'll also want to update these. Not that anything important is happening. Okay, so there's no update function here, so we actually don't need to worry about that even. So I'm just going to make sure that we have this in our main here. Oh. Let's see, do I have time? Yes. I wonder why it's not showing up. Here. I'm just going to take a look at one of my other ones just to make sure. Assets tile, that's right. No, it's just Oh, okay, thank you, Aiden. Just another silly mistake on my end. Basically, when I make the sprite group, we actually have to add what we want, which is the platform, to the sprite group. I just got a bit ahead of myself, so do platforms.add. And then we'll cross our fingers and we should have a successful kind of execution here. It's still not showing up. Okay, no, it's right at the bottom there. Just my zoom was in the way. So we got a platform going. And now just to kind of show how we would get the collision here, let's go up to the update section and we're going to use Sprite. Pygame.sprite, sorry. Game.sprite, and then Sprite. Collide rec, yep. And then we're just going to pass in the two sprites that we want to check. On our case, this is the player and our platform. And then this is a Boolean, so it's going to be true or false. So we can just throw in an if statement. And then that way, any code that we want to run, we can just add to this if statement. And in my case, I'm just going to print collision detected, just to show you that, hey, this actually works. I'm basically going to have my guy walk into this, and you'll see in my console here that it's spitting out collision detected. And if I walk out, it stops printing. It's kind of hard to see it stop, but that's how you go about doing collisions. So let's hop back to the slides here. And so if you wanted to stand on a platform, for example, you could take basically that if statement I had where it prints, and you could just take the y speed and cancel it out. And that way you'd basically stop falling, right? So that's an easy way to just implement standing on a platform. And then this just brings us into our quick question number 2. So if the enemy and the wall are both sprites, what does this code do? If I can just get a pull up on that. Okay, we're off to a strong start. People seem to understand this well, so. Okay, I believe the ballpark of like 60–70% of you have answers, but we're getting a few more answers here. So if you haven't yet, please just answer, and then we'll talk a bit about what actually happens here. So. All right, okay, so it looks like most people have answered. Just to help us save a bit more time, I'm sorry if you didn't answer, but I asked that we just end the poll there. And basically we had like 2 really contentious answers. So some of you said that this makes the enemy bounce off the wall. And then the other popular answer was it makes the enemy change its direction every time the update section is run. So just one thing to kind of keep in mind here. First, I'll tell you, like the correct answer is that it's going to make the enemy basically bounce off the wall and change direction. And the reason that it's not the other popular answer, which is just to change its direction every tick, is because it has this actual collision checking logic here. So unless the enemy actually touches the wall, it's not going to change direction. And so the correct answer is going to be the, I believe it was the second one, where as soon as you run into the wall, you'll turn around, but nothing else will happen pretty much. So just a kind of recall is that this like times equals operator is basically the same as just multiplying this value with -1, and then setting it to this value again. All right, so now that we can check with collisions with one other sprite, how do we actually make this more useful? Because say in like a platformer, you're going to want to be able to jump from one platform to another. So the Sprite Group platforms acts like a list you can iterate over. So you just need to not make the same mistake I did and actually add your platforms to the Sprite Group. And then you can use this kind of logic here where no matter what platform the character kind of lands on, its speed is going to be canceled out and the player will stop falling. And then I'll just have the player update accordingly after that. So does anyone have any questions about any of that? Any questions about collisions in general? I think it'll be a lot of fun when you guys actually go ahead and try and implement this, because you might see that the behavior is a bit different from what you might expect. Just something to look forward to. I don't see any questions, so I'm just going to carry on here. When one sprite collides with another, say we have a player and then either an enemy or something that will kill it, right? So you're basically just gonna want to yeet the player out of the sprite group and just make sure it doesn't show up anymore. And so you can actually accomplish this by using the sprite.kill method. And basically you can just take whatever you want to kill, call kill on it. And then it's important to actually remember the context of like, you only want to do this if your player collides with the spike. And so I don't think, actually, I might just demo this quickly with the platform demo I just had. So instead of collision detected, we're just going to go ahead and instead of the player, we're just going to kill the platform. And if we test this out for ourselves, when I walk down here, we should see that it just disappears. I guess one thing that's kind of important to notice is that it's still detecting the collisions. So I don't think the platform is like truly like gone, but it does kind of disappear. So and without further ado, guys, we're going to send you on another exercise. So hopefully you were following along when I brought over that platform code. I realized I didn't add this link into the chat, so sorry about that. I'll do it now. You'll just have to do what I did, where you make the platform sprite group. You make a platform. You add the platform to the sprite group, and then you change the draw method that was drawing the platforms before to basically the sprite group. I named it platforms.draw, and then you pass in the screen. And if you need some review, we just have a top slide. I think it's one of the first two that covers bringing in the platform.py class. But if nobody has any questions about that, I will send you off to your break rooms. Okay. I think we'll give him like, I don't know, it's kind of complicated. So I'll give him, I just want to say 15 minutes just because I do want to talk about it a bit afterwards.
Yeah, you do need enough time at the end to go over it yourself. So
yeah. But I mean, hopefully they have the slides because it pretty much shows you how to do it. I think one thing that might slow them down is they won't have like the platform class in, but
Right.
I literally like told myself mentally to paste it into the chat, but of course I forgot.
I think the mentors got that. I think
Yeah.
they got it.
I mean, Aiden saved me, so I'm sure his mentees will be fine.
Yeah.
Just if I had $1 for every time I made some like tiny mistake that like give me a heart attack because it didn't work, I'd be rich. I don't know, it's hard coding live.
Yeah, no, I feel that because if you mess up,
Yeah.
it's gonna be pretty embarrassing, like trying to debug for 10 minutes.
Yeah.
But I think you get used to it. I think Richard last time,
Mhm.
he had a few instances where that happened, but then since there's like 30 other people in there, someone will figure it out. So
Exactly. Yeah.
like you won't waste time.
No.
It'll go pretty quickly.
What's always what I find funny is that like it's never like I don't know. I tend to like do good. Okay. But it's kind of my okay. Welcome back, everybody. Hopefully you had enough time to finish the exercise. It wasn't as much as I would have liked, but just to make up for that, I'll try and go over it quickly here. So I'll just show you what I'm working with. So I'm just working with like the same kind of jump example I had before. So it'd be the same as like the exercise you guys finished. I just brought the platforms in from before, but I haven't done the collisions yet. So I'll just follow through that if I don't do anything. And so basically what we need to do here is just go into the update section and check for some collisions. So we're going to take that code snippet where we had in the slides where we iterate over the platforms. So for platform in the platforms, game.sprite and it's collider. And then we want to check each of these with the player and then with the actual platform it's colliding with. If you don't know how this works, I should probably go and review your for loops, but basically this will give me a true or false value I can use to do some more comparisons with. And so just like the most basic implementation would be, if you collide with any platform, I can just do the code directly in here where you change the player's speed or like Y velocity or Y speed, basically how fast you're falling to 0. It will stop, yeah. And then just because even with gravity active, like we don't need to stop gravity because you're still going to be colliding with the platform. And so basically you'll just be stopped no matter what. So hopefully I don't eat my words here and we'll actually see this happening. So it's exactly as expected. My player stopped. I made my jump a lot more bouncy, but my player stopped when I hit the platforms, and that's both of them. If you just did one, you might try and jump from one to the other and your player would just fall into space. But you might notice that our player here is kind of like halfway through the platform, and then it might be a bit too precise for me, but oh, there we go. That's a perfect example. So what happened here is I was actually falling fast enough so that by the time it detected a collision, I was already like moving halfway into the platform. And so like, this isn't what we want, right? So there's just a really simple fix for this actually. It's not like a perfect fix, and I'll show you guys what I mean by that, but basically all you would have to do is take your player and then just change the position. So it'd be player.arc.x, and then I gotta think of where we actually want to put the player. So it's not actually the x value we want to edit, but it's the y value, because we want to keep them and paste them just above the platform. So change the y, and then we just have to calculate where they are relative to the platform, right? So basically it's going to be where the platform is, and then we just want to take how tall the player is, and then subtract that from the platform's y position. Then we'll have basically the top of the player, where the top of the player should go. So I'm just going to go ahead and do that. Platform.rect y, so that's the y value. And then all we have to do is subtract from that player.rect.height. And then that should place us just above the platform. I feel like I might be missing something, but we'll see. Okay. So you'll basically see that I'm kind of bouncing up and down here because I haven't stopped gravity at all, but it should work normally outside of that. Then a benefit of this implementation, if you don't lose your mind from like the player kind of vibrating, is that if you walk off a platform, it should handle that for you. So does anyone have any questions about any of the content we covered today, about collisions, anything at all? Just please just fire away. Then if you are falling a bit behind on the exercises, please do try and put some extra time to catch up. Hopefully it's fun, and there's actually some incentive for you to do that. Just a quick reminder is that next Monday after our session, we're going to be having a 20-minute kind of presentation from the Solely Car team here at the University of Calgary. They're going to be talking about how software is used in their electric car platform and a bit about the technology behind that. So if that sounds interesting to you, please just come and stay for a little late next Monday, and you'll get to see that, which I think is pretty awesome. It's nice that they're taking the time to do that for us. Thank you, Heidi. If you need any help on any of the exercises, please go to the Discord, because they only kind of get more complicated, right? So just ask questions and try things out for yourselves, and just kind of play around with this. And soon enough, you'll kind of be extending on this for yourself to build whatever you want. So it's better to kind of figure things out now than down the line. And with that said, we're pretty much at the end of our time here. So does anyone want to see me kind of implement anything, or maybe limit the number of jumps you do in midair? Anything at all? Okay. All right. Well, in that case, I'm just gonna let you guys go free. Thank you so much for coming as always. I really hope you guys enjoyed it, or at least learned something. And hopefully we'll see you again next week. Thank you guys so much. Take care, everybody. Can I see like my computer setup, or? Oh, jump. Okay. Yeah. So this isn't all of it necessarily, just because some of it is in the player class, but you might be missing the platform initialization here. So I created 2 platforms. I have a group, and I add them to the group. And then my player, just the kind of setup up here, is just the Y speed and the cooldown are probably the most important parts there. So Hopefully that answered his question or your question. Okay, awesome. All right, if you don't have any questions, please leave the meeting because we're gonna be staying, just the rest of us here. So thank you for coming. Take care. I think it's just the rest of us now. So
Okay. All right, Ishan, you could go ahead and lead room 7. I'm gonna go ahead and open up the breakout rooms here.
Sounds good.